Hi everyone, welcome to stream number 12 in the Learn Along series. We are currently studying NLP with deep learning from Stanford. Uh, Today is the working session. I've scheduled one of those working sessions. So the idea is to get more hands-on. I think that's what uh, we have been missing out on, uh, getting more into the code. So I'll basically try to do assignments or maybe even, I don't know, to find further code snippets on the web related to the topics that we've already uh, covered from a lecture point of view. Uh, Before I move into that, let me quickly check if my sound is okay. Give me 1 second. Yeah, okay. I think it's okay. I don't basically. Yeah, okay. Uh, so what we will do is, as I said, try to get into the code. So I'll replicate the assignments into my Google Colab and then uh, try to work our way into assignments one by one. I will not try to get into too much of a theory. I'll try to mostly focus on, uh, I mean, at least a little bit of a practicality point of view, uh, not getting more like into the concepts as such. So, Colab notebook. So, what I'm doing is I'm basically going into my Google Colab and we'll download the code right there. Um, so far, I mean, we've covered a lot of stuff. Word to act, then we later on went into little bit linguistics, language modeling, and stuff like that. We got introduced to neural networks, RNNs, fancier RNNs, LSL, EMGRU, and got a little bit of insight into attention. Um, so far, we've covered a lot of good uh, material, and I think we've done like 9 lectures from the course. So if you're new here and you haven't watched those, go back into the same playlist and then you can see, you have all of the links in the description about the original videos, original Stanford videos as well, so you can definitely directly go into that as well. I am actually downloading the code uh, snippets as we speak, at least for the first few. I'm not sure how many we'll be able to do, but my objective is basically just to, you know, uh, work for around an hour and a half or so that uh, we have enough time, but not too much time just spent on to uh, doing just this. I don't know why, but my spectacles give a glare of the blue light. Is that, I don't know if it's distracting. Yeah, can't do anything. Sorry about that. but these look downloaded. I am unzipping the first one, extract here. Okay, I think we're good to go. Yeah, I'll quickly set up the first assignment. Maybe also look at the oh, this is not synced yet. Okay, uh, we look at what it was. We can also open the slides in parallel and then try to figure out what went there. If you don't understand, I think this also be a good quick overall review. uh, Sorry if you're hearing a lot of disturbance. I'm just moving some things around. uh, I don't know what happened, but let's press some key. Okay, why is it not syncing? Come on, man. So I'm basically what I'm trying to do is I'm running everything in Google Colab. So I have to essentially download it into my Google Drive, which is the uh, offline Google Drive, and it just syncs into the web version, and then I can run the Colab notebook from there. I don't know if you find if you know any efficient way. I've heard of NB Viewer, but never really tried that. There may be a lag right now. I don't know if I press something which I shouldn't have. I don't know what was something is killing my RAM right now. And I'm getting a bitrate warning. Mostly OBS, yes, and I'm getting a bitrate warning. Mostly OBS. Okay, never mind. We'll keep going. It should fix itself. I think the code is loaded. Is it? It's not. I don't know why this is taking ages. This should not, but can't really do anything. Now it should be done. Is it? Is it? Oh, fantastic. Okay, let me switch to our learning mode. Yeah, I think I should. Alright. Uh, so I'll zoom in a little bit. So guys, yep, I think that's better. So this is the first assignment, way back when we did word vectors. Yep. I think all is okay. Now, what we'll try to do is read through these so that we'll understand what's going on and try to. I don't know if there's any handout. There's no handout for this one. Oh, there was a Gensim word vector example. I think we should do that first. Sorry. And go back and I think I have that downloaded already. Yeah, I believe we kind of did that, but I want to review that just in case. The bitrate bad again? Yeah, I don't know what's going on. Might kill the quality a little bit, but it should fix itself very shortly. Yeah, I mean, it's not bad. Okay. Sorry, I'm already faced it like 15 minutes. But okay, here we go. Gensim word vector visualization. Also preview for this code. See what the preview is. Okay, let's just open both of these if we can. Is it the same? Oh, I think it's the same deal. Okay, then we don't really need to look into this separately. Okay, now Gensim word vector visualization. Is this stream lagging? I think it should not now. I don't know why it's still something's killing my RAM for some reason. I know it's Google Chrome, but this shouldn't. Maybe I just need some tabs. Okay, keep going. Uh, I think you guys can see. Uh, yeah, NumPy, Matplotlib, ggplot, scikit-learn for PCA, then Gensim, word2vec, that's what we want to do. For looking at word vectors, I'll use Gensim. We also use it in homework 1 for word vectors. Okay, Gensim isn't really a deep learning package, it's a package for word and text similarity modeling. Start with LDS style topic models include SVD, neural word representation, but it's efficient and scalable, quite widely used. Okay. Homegrown Stanford offering is glove word vectors. Gensim doesn't give the first class support but allow you to convert file of glove vectors into this. You can download the glove vectors from this page inside this zip file. Now I'm not doing that right now, but I think that's why we'll not be able to run this code. So this should be fine. Or maybe I don't know, glove word2vec. What runtime do we have? Yeah, if you guys are not really familiar with Google Colab, uh, always just first check the runtime should be a GPU. They allocate a GPU to you, I think, for 12 hours, and also some disk space. As you can see, you may have some files here, but yeah, let's see if this runs or gives an error for. Yeah, okay, I don't have this file, but yeah, never mind. I'm not downloading this. Then I think the idea is to I use the 100 dimensional word vectors below as a mix between speed and smallness versus quality. If we try out 50, they basically work with similarity, but fluently others with different analogy. 300, obviously better than 100. Oh yeah, I think Google syncing in the background is also another problem. Sorry guys, if you are getting a lot of buffering and all of that, this is my YouTube studio says so. Okay, so data path, what to glove file here, define where it is, and word to vec. Basically, convert glove input file in glove format to word to vec format and write to word to vec output file. Okay, so the first is like path to the glove format, second is path to the output file. Okay, and it's an integer integral return. You can just, I think, hover over a particular code, click on that maybe. I don't know, sometimes it's open. Model keyed vectors. Load the input hidden weight matrix from original word to vec true format. Information stored in the file or whatever. Okay, I think yeah, we were trying to find similar words. I think we have the code here for at least running for this. No, yeah. In the lecture, I remember trying to find similar words like Obama and banana, and Obama had other presidents, banana had other fruits. And then the analogy of like these three words, stuff like that. Okay, I mean we can't do this, so not trying to spend a lot of time here. But I think it's no point of the code. Trying to do PCA scatter plot. Okay. Trying to see how what it may look like. Oh, something like this. Okay, fine. All good. Yeah, sorry for the disruption. Let's get to assignment one finally. I need more space in my Google Drive. Do this. Do I have any other files? DS store, YML file, readme. Do we need to look at readme? It says good connection, but it's not excellent. I didn't know the readme file will take forever. Also this. Yeah. Okay. Before you start, make sure you read my. Okay, yeah, I need to do that. Thank you. We'll be using Python throughout the course. If you've got a good Python setup already, great. Make sure it is at least Python 3.5, not easiest thing to make sure it is at least 3 GB free on your computer. Head over to Anaconda. Yep. Conda, environment, activate. I think this is like the best way to do. I'm just using Colab. One is a Jupyter notebook. Okay. All important statements defined here. Note, do not add to the list. Got it. System. Okay, we got Jensen, Matplotlib, NLTK, Reuters database, uh, scikit-learn. Okay. Word vectors are often used as fundamental component for downstream NLP tasks. Example, question answering, text generation, translation, so on. So it is important to build some intuitions as to their strengths and weaknesses. Okay. Count-based word vectors. Most word vector models start from the following idea. We shall know a word by the company it keeps. Many word vector implementations are driven by the idea that similar words, near synonyms, will be used in similar contexts. As a result, similar words are only spoken or written along. Yep. Examining these contexts, we try to develop embeddings of words. Many old school approaches to construct word vectors. Findings work is matrix. Okay. Co-occurrence matrix counts how often these. Yep, I remember we discussed this in the class. If the window size is n, then this is the n preceding n subsequent words. Yep. We build a co-occurrence matrix M. Symmetric word matrix is Mij is the number of times. Okay. Co-occurrence is fixed window n equal to 1. All that glitters is not gold. Yeah, thank God I muted in time. Before I sneeze. Okay. Uh, all that is okay. Yeah, I'm just reading through this. Okay, so that's why we reduce dimensionality. In particular, we use SVD, which is a kind of generalized PCA. Okay. Top K principles. Here is a visualization of a dimensionality reduction SVD. Wow, no picture here. Is there supposed to be a picture here? Images. SVD. Oh, I think I remember. Yeah. We obtain a full matrix decomposition with the single values ordered in the diagonal list and our new shorter K word. Okay. Okay. This reduced dimensionality co-occurrence representation preserves semantic relationships between words. Doctor, hospital will be closer than doctor and dog. Okay. But if you barely know what eigenvalue is, slow, friendly introduction to SVD. You don't learn more thoroughly. So a lot of lectures and maybe, oh my god, no, sorry, what happened? Uh, okay. For the purpose of this class, you only need to know how to extract the k-dimensional embeddings by utilizing pre-programmed implementation. That is exactly what I want. And on a truncated SVD, yes. Okay, here we'll be using Reuters business and financial news corpus. If you haven't run the imports at the top of the page, please run it now. Click it up, press shift run, shift return. Oh, shift enter. Okay. Corpus contains all of this stuff. This document spans 90 categories and is split into train and test. I'll quickly look at here. Access Corpora. Okay. So we provide a read corpus function below that pulls out only articles from the crude category. The function also adds start and end, token change, document, and lowercase word. You do not have to perform any other kinds of preprocessing. Okay, let's just run the code at the top because I did not. First of all, do v1 runtime type. Okay, GPU space select. Yep, that's okay. Right. Will this take a while? Or is it done? I think it's done. Oh, wow. So it doesn't tell you where it's at, or it should. Yeah, yeah. I think the icon here turns gray when it is still working on something. But okay, now we are defining read corpus. Uh, the category will be crude. Read files from the specified Reuters category. Parameters are category name, return list of lists with words from each of the preprocessed files. So we define files as Reuters file ID category, category is crude, return start token plus w dot lower or w list f plus n token. Okay, so this is what it's adding start and end. So we provide read corpus function, pulls out the crude and adds start and end to each of the documents. Brilliant. Okay, let's have a look. Oh, I think the code was hidden behind me. Now you can see plus start token plus n token. So let's have a look what these documents are like. Reuters corpus is equal to, now we are reading the corpus. Print come back to it. Okay, so this is the corpus. Oh, so we have start blah 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 blah. So Japan to revise long-term energy demand downwards, the Ministry of International Trade. Okay, okay. And then there's an end. Similarly to, how big is this? Okay, not that big. Is it supposed to be this one? Oh, just the three. Sorry. Finally, we have excellent connection. Thank you. Uh, Implement distinct words code. Write a method to work out the distinct words, word type that occur in the corpus. You can do this with for loops, but it's more efficient to do with Python list comprehensions. In particular, this may be useful to flatten out the list of lists. What is this? Flatten a list in one line. Okay. Many different ways to do that. If you're familiar with Python list comprehensions in general, here's more information. Let's see, more information. No, that's a lot of information. You may find it useful to use Python sets to remove duplicate words. Okay. So what do I have to do? Work out the distinct words that occur in the corpus. You can do this with for loops, but it's more efficient to do it in Python list comprehension. So define distinct words in the corpus. Determine a list of distinct words for the corpus. Corpus list of strings. Return corpus words, list of strings, list of distinct words across the corpus sorted. Use Python sorted. There is a more code here. Sorted function. Okay. Num corpus words. Yeah. So we are returning corpus words and num corpus words. Where corpus words is a list of distinct words. We use the sorted function, and then the num corpus word is an integer where there is a number of distinct words. Okay. Let's start with -1. Oh, I think just the initialization, or we have to remove this. Okay, now my experience with Python programming is next to zero. So if you are a little more adept, you may need to skip through a few minutes of me figuring out what this is, but if you're brand new like me, let's try to work this out together. So there are two things. One, I think we need to first flatten the list of lists, and then we need to use sorted, and then there's a count. Okay, so for the first here, files is equal to this category and return this. So let's just use at least the list of lists. At least let's just try to first flatten, because that's step number one. Yeah, we'll just do this list of lists. Trying to make sure. I know indentation not really a concern, but it is. Ah, so what was words? By the way, what is the list of lists? Is it Reuters corpus? Or we can just do type to know what is going on here. This is the list. And what about G corpus? This is a function. Okay. Yeah, I'll just do Reuters corpus and let's just see what happens in here. So flatten list y for x in Reuters corpus, so find x. Nope. I mean here basically saying there's a list of this range 4 and range 7. I mean I know this is coming from an example, but still. Sorry if my audio is too low. I don't want to speak very loudly when early in the morning here, but yeah, I think we got this one right. The Reuters corpus, but yeah, let's just see what happens. I mean, this is all irrelevant. Will this work? Oh yeah. So we flatten the list. We know what corpus words. Oh no, this is incorrect. We also have to do a sorted, and it says where's the Python set? You may find it useful to use Python test to remove duplicated words. Okay. Is there a duplicate? The sets cannot have two items of the same value. Oh, just remove duplicates as is. So what do I have to do? Remove list duplicate. I mean, I understand we have to basically, I think, make this a set, and then create this back to a list, isn't it? If I just try to run corpus words, it's like it was here. Wait, what? Do I run this in the same cell, or is it because it's the function? Yeah, great. Now, yeah, I can just do a set. Oh yeah, this is what I have to do. See, I wasn't just sure. Sorry about that. So, oh, I do that later on. So corpus words equal to, maybe you know what, I should not do this. Um, exhaustive, and then okay, now I have to find the number of corpus words, and this is a way to calculate the number. Length. Run this sanity check. No use conduct just to check the correctness before it. What? Wait, hold on. There are only 10 distinct words. Define toy corpus. Test corpus is equal to all that glitters is gold format, whatever. Just want to do this first. I'll zoom out a little bit. So I at least have the entire code in one screen. Okay, let's try to go through this. Define toy corpus. So there's a test corpus which is a test corpus word, now word, distinct word, test corpus. Answer test corpus word sorted start token all yeah number is length, right? So I did, but it's asking me to use sorted rather than this set. Fantastic. Oh, word types. Yep, sorry, I was muted. Determine a list of distinct words for the corpus. Corpus, list of strings. Corpus, a document. Isn't that going to be corpus document? Where is corpus? What am I missing? Yeah, that's the deal. Should I try the other flattening method? By the way, one more thing. So there's a list of lists. Let's say we run this here, do this. Now I want to see the type of route. List of list is list. There is a list. There is not a list. Great. We found out nothing. Maybe this will try. So this return is a list of lists with words from each of these processed files. Which is the right source? I can't understand why this is not this. Sorry, I'll just try the new way. Corpus words exhaustive. Do I have to define this? I think I do. Number 0. I think it doesn't make sense. It shouldn't make sense. Should be different. Sorry. Now X in the list of this, which is Reuters corpus. I have to do crude here? Lead corpus crude. What will be that? Type this entire thing. It is not defined. Maybe try this with this one first. I think it's still pulling the earlier version, which I see is the issue. The number of corpus words the length of the length of corpus. Like what? Sorry, thanks for pointing that out, Akash. But yeah, I mean, I'm just struggling through the code, so not really doing any significant commentary here. But let me know if you can help me out. What I'm trying to do here is basically build this function to calculate distinct words, and there are 3 steps I need to do. One is to flatten the list, uh, which I'm doing via this list comprehension method. Then convert or basically remove the duplicate words. So I am making this as a set which will remove the duplicate words, and then back to the list, and then calculating the length of the corpus, which I believe should be corpus words. But yeah, definitely struggling through this, because in the test code wait, something happened, which is, this is different, because earlier I was getting an error in the length, which I think is fine now. Incorrect corpus words, correct end, start, all of that. All this ends, all gold, all end, start. Okay, so it's not sorted. Okay, I think I just need to sort this, which I think there was a way in the set. it is not here. The list comprehension does not sort. Not sure if this sorts. Yeah, I'll just clean up the mess here. Okay, now how do I sort this? Because the number is fine, and alphabetical sort Python list. Oh, so there's a sorted function. Okay, I think that's what they've applied here as well. So I just need to do a sorted sorted on the list. Hopefully this works. Ah, thank you. Okay, so we are calculating the length as well as what the correct words are. So there were two tests here, test the correct number of words and test the correct words, which we passed in like half an hour. Okay, implement compute co-occurrence matrix. Write a method that constructs co-occurrence matrix for a certain window size n, default of 4. Yeah, okay, let's just choose n4. Okay, so they already have. Considering words uh, n before and n after. Here we start to use numpy to represent vectors, matrices, and tensors. If you're not familiar with numpy tutorial. Write a method that constructs co-occurrence matrix. Okay. Give me 1 second. Okay. Uh, Compute co-occurrence matrix of a given corpus and window size. Each word in the document should be at the center of the window. Word near edges will have a similar number of co-occurring words. For example, if we take the document start blah 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 and window size 4, yep. All will occur with start, that glitters is and not. What? I didn't get this. If we take the document with window size 4, all will co-occur. Oh, I see, because the window 1, 2, 3, 4, 5. So not. Yeah. So it's, yeah, fair. all is at the center, and then there's +4 and -4. So we are giving the parameters corpus, list of strings, and window size, integer, return m, a symmetric numpy matrix of shape, number of unique words in this corpus, number of unique words, symmetric numpy matrix of shape, number of unique words, okay, occurrence matrix of the word counts. The ordering of the words in row and column should be the same as the ordering of the words given the distinct words function. Word to end, the dictionary that maps word to index, row column number for matrix m. So we define words and number of words as the distinct words. M is equal to none at the beginning. Word to index, sorry. I mean, sanity check kind of gives us a little bit of an answer. Does it? I don't think so. Or maybe for this. Word to index answer. It's a dictionary of, what is zip function? I think also in the Jensen preview kind of did this, didn't we? Or maybe not. Yeah, we gotta do, right now I think it's just matrix and SVD follows later. Wait, aren't we just doing this? M equal to np dot array distinct word. Unhashable type list. Great. New error. This is the distinct words corpus. Okay. Fair. Fair. I think we just need words and number words. But I don't see the difference. Is it the same? Why do we need two different words? Let's understand Python dictionaries, right? Also, we're zipping two dictionaries. Which two? Well, I think zip is used below because we are trying to zip these two. But we are also doing the same thing, right? For words and edges have a similar. Oops, I think the mic is. Yeah, okay. Um, NP array. I don't see the point of. But if you've already defined this, I might as well just go with year and word 20 series. I mean, we are zipping these two. I don't see the point. Maybe I just do words here and then the number of words here. See what happens. Integer has no length. What is an integer? The number of words is an integer. Okay. I think I know. M8 is the incorrect shape. Yours is 10 by 10. Oh, correct is 10 0. What? Okay, I'll be back in 1 minute. Okay, I'm back. Uh, our M matrix has incorrect shape. Ours is a symmetric 10 by 10. It should not be the case. Is it? It is a symmetric numpy matrix of shape 10, number of unique words, number of unique words. I don't get the point. Correct is the first one. Right, is it the opposite? And what if I do this? Okay, let's run this function myself. Corpus is what is the corpus? Oh, it is corpus. M. That's simply corpus. But dot shape, right? No? Never mind. Cannot interpret 10 as a data type. Yeah. What we do? Words, comma, words. That helps. Field element must be 2 or 3 tuples, but end the only thing left is number of words. Booyah. Cannot do it 10 as a data type. Thank you. A symmetric numpy matrix of shape Oh, the other way around, sorry. I think I need to set off this. Yep, let's try to see if our word to wind is fine. Cannot interpret 10 as a data type. Oh no. 8. I see. think this is a good idea. I know we're above time, but let's try to this one last method. So we are defining how we generate a matrix here, similar to carpet 5. This needs to be changed as well because it's not initializing. M. The hell? Finally. NP zeros, length of some numbers. Hmm. Pandas. Interesting. I think this is what I'm looking for. Okay. Honestly, I think I'm there. I just don't exactly know what how to go through this, but that's the thing. For starters, I realize I will take a whole lot of time with like very little progress. We barely we just did two sub parts. I mean, not even two. Stuck on the second sub part uh, in an hour and a half. But if I'm trying to learn from scratch, I think this would be a good learning exercise and pick up pace as we go along. We probably will do the same thing tomorrow. Uh, I'll have to see, or maybe do another lecture and then come on this sometime later. But I definitely would want to continue working on this so as to, you know, be better at just getting more hands on. I've never really been, I'm not adept with Python at all. So uh, I think let's call it a day and then try to get on this later so that uh, I mean, my objective is to do this live in front of you guys. If I mean, obviously, if you join in and help me out, definitely it's great. But more importantly, I'm trying to motivate you to also get dirty within the code and work on this by yourself rather than just asking people around or just looking at the code and just understanding on face value. Uh, but okay, um, not a great progress day, but still, uh, still, I mean, it relieves off a little bit of that anxiety that you have in the beginning when you're trying to learn something super new. Uh, I think, I mean, not that I learned a whole lot today, but figuring out how I should be proceeding with this gives me a whole lot of, it gives me a little more confidence to be working on this going forward. Uh, and yes, you will see me struggling through this because, as I said, I am not, I'm not a programmer. I've not really done any Python courses at all, even if I wanted to. But yeah, will get through this. May take much longer than you would want. I mean, if I was sitting in this course, I was definitely would not be able to complete this assignment because I've been taking so much time in the basic stuff, like 1, 2, 3 points. I mean, how am I going to do this prediction and all that? But okay, uh, let's get on this later. I'll uh, I'll stop for now, and I'll see you guys in the next one. Thank you.